Here are 5 number cards. We have 0.47, 10, 100, 1000 and 4.07. Use 4 of the cards to complete these calculations. 47 divided by something equals something. Now we can see that here we're going to be dividing by 10, 100 or 1000. So what we can do is write out 47, and then because that's a whole number, we can put a decimal point on the end. Then we can copy down our decimal point, and remember, to divide by 10 we can move the digits 1 square to the right. To divide by 100 we can move the digits 2 squares, and to divide by 1000 we can move the digits 3 squares. Now we can make the number 0.47. If we move the digits 2 squares to the right, we get 0.47, because remember, if we have an empty 1 square, so an empty square before the decimal point, we can write a 0. So we moved the digits 2 squares, which meant we divided by 100 to get 0.47. So we can cross those off. Now, something times something equals 40.7. So let's take the number 4.07. How can we get 40.7 from that? Well, if we copy down the decimal point, we can see that what we're doing is moving each digit just 1 square to the left. And if we move the digits 1 square to the left, that's multiplying by 10. So we can have 4.07 times 10. This also works if we switch the numbers around. So if we have 47 divided by 0.47, that will be 100, because you can always switch the divisor and the quotient of a division problem, and with multiplication problems, you can switch the numbers around because order doesn't matter with multiplication. Sarah draws a quadrilateral. It has these properties. It has 2 long sides the same length. It has 2 short sides the same length. It does not have any right angles, and it does not have reflective symmetry. Write the mathematical name for Sarah's quadrilateral. So a quadrilateral is a 4-sided shape, and here Sarah must have drawn a parallelogram. Remember, a parallelogram can look something like this. So it has 2 long sides the same length, because line BC is the same as side AD. It has 2 short sides the same length, because line AB is the same as line CD. It does not have any right angles. Remember, a right angle is like the corner of a piece of paper or the corner of this screen. We can see that this angle and this angle are obtuse, and this angle here and this angle here are acute. And it does not have reflective symmetry. Remember, you can draw a line of symmetry if you have the same reflected on both sides, but with a parallelogram we have no lines of symmetry. Write the missing numbers. So here we need to convert between improper fractions and mixed numbers. In the example they've given us, the improper fraction is 7/4, and as a mixed number, that's 1 3/4, because 7 divided by 4 is 1 remainder 3, and the denominator stays the same, or 1 times 4 is 4 plus 3 is 7, and that's the numerator of the improper fraction. Now here they've given us the mixed number 5 1/2, and we need to write the improper fraction. To change a mixed number to an improper fraction, we can multiply the whole number by the denominator and then add the numerator. So 5 times 2 is 10 plus 1 is 11. so our numerator will be 11. 11 halves is the same as 5½ Now we're given the improper fraction 17/5, and we need to change that to a mixed number. Remember, a fraction is really a division, so our denominator will stay the same, and then we can divide 17 by 5. That's 3, remainder 2, because 3 times 5 is 15, and then we need 2 more to get to 17. So we have 3 2/5. We have 3 as our whole number, and then the remainder is our numerator. So our missing number here is 2. This pie chart shows the ingredients to make a food mixture for wild birds. Estimates the percentage of the mixture that is suet. So a percentage is a fraction with a denominator of 100. But rather than imagining the pie chart has been divided into 100 pieces, what I like to do is estimate the fraction and then change the fraction to a percentage. So we have suet here, and if we copy something that's the same size, we can do that 1, 2, 3, 4, 5 times. So I would estimate that 1/5 of the mixture is suet. We can change 1/5 to a percentage by finding an equivalent fraction with a denominator of 100. 5 times 20 is 100, 1 times 20 is 20, so because 1/5 is the same as 20 hundredths, that's 20%. You get the mark for an estimate of between 15 and 25%. Now, Mina uses 100 grams of millet in the mixture. Estimate how many grams of sunflower seeds she should use. So we have millet here, and we know that that's 100 grams. Now I would estimate that sunflower seeds is about 3 times as large. So if millet is 100 grams, to work out sunflower seeds, we can multiply 100 grams by 3, so that gives us 300 grams. You get the mark for an estimate of between 201 grams and 399 grams. The pointer on this dial turns in a clockwise direction. The pointer is at 0. Which number does it point to after a turn of 270 degrees? So if we remember, a whole turn is 360 degrees, which means that 270 degrees is a 3/4 turn. So we're starting at 0 and then turning 3/4 of the way around. So when that happens, the pointer points to 9. Now the pointer moves from 10 to 11. How many degrees does it turn through? So it turns from 10 to 11, and that's 1/12 of a whole turn. Remember, a whole turn is 360 degrees. So if we divide 360 by 12, we get 30, which means that it turns through 30 degrees. When it moves from one number to the next, that's a turn of 30 degrees, because if we have 12 turns altogether, 12 times 30 is 360, and 360 degrees is a turn all the way around. And knowing this would also help us to work out the question above. So if we didn't spot that a 3/4 turn is 270, we could find how much it turns from one number to the next by dividing 360 by 12, and then we could count in 30s until we got to 270. Here is a square drawn on a coordinate grid. What are the coordinates of the point at the centre of the square? So remember, with coordinates, the first number is the x coordinate. So what we can do is write the information that we have on our axes. If we go down from here, we can see that the x-coordinate is 3, and if we go down from this point, we can see that the x-coordinate here must be 9. Now this point is in the centre of the square, so that will have an x-coordinate that is halfway between 3 and 9. So the x-coordinate here will be 6, because that's the same distance from 3 and 9. So we know that the x-coordinate is 6, so now let's look at the y-coordinate. Going across from this point, we can see that the second number is 4, so that's a y-coordinate of 4, and from this point, we can see that we have a y-coordinate of 10. So again, the dot, or this point, is right in the centre, so we'll be halfway between 4 and 10. So that's 7. So our coordinates for the point at the centre are 6, 7. Here is part of a temperature scale. What is the temperature shown at A? So we can see that we have 0, then we have 5 lines to get to -5, then to get to point A, that's 2 more lines, so the temperature at A is -7 degrees. Now, what temperature is 20 degrees higher than A? So A is at -7. To get to 0, we need to add 7, but that's adding 7, and we need 20 degrees higher. We need to add 20. Now 20 minus 7 is 13, so if we've added 7 and want to add 20, we need to add another 13 so that we've added 20 altogether. So the temperature that's 20 degrees higher is 13 degrees. The table shows information about 3 solid shapes. Complete the table. So first we have a cuboid. We can remember that a cuboid looks like this. It has 12 edges because the edges are the lines that join faces. So we have 4 edges at the front, we'll have 4 edges at the back, and then we'll have 4 edges around the middle, so that's 12 edges altogether. Now we need to find the number of vertices. So with 3D shapes, the vertices are the pointy bits. We have 4 pointy bits at the front, and we'll have 4 pointy bits at the back as well. So that's 8 pointy bits, 8 vertices altogether. Now we need to think of a triangular prism. So that's a triangle that's been stretched out. So we have triangular faces on both ends and then rectangles connecting the edges. So how many edges do we have? Well, we have 3 edges in our triangle at the front, 3 edges in our triangle at the back, and then 3 edges connecting them. So that's 9 edges altogether. And now for the number of vertices, we have 1, 2, 3 at the front, 1, 2, 3 at the back, so that's 6 vertices altogether. And now we have a triangle-based pyramid. So the number of edges, we can count 1, 2, 3, that's the triangle at the top, and then we'll have 4, 5, 6, so 6 edges altogether, because each corner of our triangle will have an edge connecting it to the top of the pyramid. So that's 3 edges in the triangle and then 3 edges connecting it to the point, so 6 edges altogether. Now we need to find the number of vertices. We'll have a vertex in each of the corners of our triangle, so that's 1, 2, 3, and then we'll have a 4th vertex as the point of our pyramid, so 4 vertices altogether. A cake costs 15 pence more than a biscuit. Megan bought a cake and 2 biscuits for 90p. How much do a cake and a biscuit cost? So for this question, we can either use trial and improvement or we can draw a bar model. We know that Megan bought a cake and 2 biscuits and that cost 90p altogether. Now a cake is 15p more than a biscuit, so underneath our bar for cake we can have another bar and then 15p. And if we copy down our bars for biscuits, we can see that we have these 3 bars plus 15p has to total 90p. So if we subtract 15 from 90, that tells us that these 3 bars together have to total 75p. And if 3 bars are 75p, we can find the value of each bar by dividing 75p by 3. That gives us 25p. So we know that each cake costs 40p because 25 plus 15 is 40. And we know that each biscuit costs 25p. 1 is both a square number and a cube number. 4 is a square number but not a cube number. What is the next number that is both a square number and a cube number? So we need to remember that a square number is what you get when you multiply a number by itself. So 1 is a square number because 1 times 1 is 1. And with a cube number, that's what you get when you multiply a number by itself, but then multiply it by itself again. So 1 is a cube number because 1 times 1 times 1 is 1. So 4 is a square number because 2 times 2 is 4, but we can't multiply a number by itself and then by itself again to get 4, so it's not a cube number. To solve this question, let's find cube numbers and then see if they're also square numbers. So 2 times 2 times 2 is 8, because 2 times 2 is 4 times 2 is 8. So that's a cube number, but it's not a square number. You can't multiply any number by itself to get 8. 2 times 2 is 4, and then our next square number, 3 times 3 is 9. So let's try 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. But that's not a square number. You can't multiply a number by itself only once to get 27. But now, if we try 4 times 4 times 4, 4 times 4 is 16, and then 16 times 4 is 64. And that's a square number as well, because 8 times 8 is 64. So the next number that is both a square number and a cube number is 64. It's a square number because we can multiply a number by itself to get 64, and it's a cube number because we can multiply a number by itself and then by itself again to get 64 as well.